Greetings. Welcome to this lesson. We are looking at the science paper 1 and science paper 1 under the ECZ curriculum. This is the physics. Particularly, we are looking at the section C. This is a question under the velocity time graph. Of course, if you are watching us for the very first time, make sure that you subscribe, follow, and share our video. So as you are preparing for the exams, it's important that you go through such kind of questions. So we are just going to quickly revise this question together. All right. So this is the question that they have given us. Figure 1.1 shows a velocity time graph of a car of mass 1,200 kg. That's the mass that they have given us. So this is the velocity time graph. We can see this is time, then this side we have speed. Speed, the SI unit is meters per second. What are they asking us? Calculate the acceleration. Okay, so it's important in every question that you take note of the important point. So they have said what? Acceleration. So we are calculating the acceleration of the car in the first 2 seconds. So they want us to calculate the acceleration of the car in the 2 seconds. All right. What is this acceleration? Acceleration is just the rate change of velocity, of course, moved with the time. That is acceleration. So we are going to solve this. We are going to say acceleration is equals to final velocity minus initial velocity over time. Okay. So when you vividly look at this velocity time graph, this car started from rest. So this is the initial velocity. The car started from rest. Then the speed started increasing until it reached. So this is what? This is the final velocity. Until it reached the final velocity of 30. Then the car was moving at a constant speed, at a constant until after 4 seconds, that's when the speed started dropping down. Right. So this is our initial velocity. So our final velocity. So here we are going to say 30 minus 0 divided by what is our time? We have said in the first 2 seconds. The reason why we have said 0 is because the car started from rest. So the initial velocity was 0. So that is 30. Okay. So what is our acceleration? So our acceleration is what? Is 15 meters per second squared. So that is our acceleration. So acceleration, that is our answer, which is 15 meters per second. Let's proceed. Explain why the acceleration is 0 meters per second between 2 seconds and 4 seconds. Here, why is the acceleration 0 meters per second between so they want us to explain why. So this is because the velocity of the car was what? Was constant. Here, this is the constant speed. So this is because the velocity of the car was constant. So we are going to say this is our P because so that is why we're explaining why the acceleration is 0 meters per second between 2 and 4 seconds. So this is because the velocity of the car is constant, or rather, it was uniform. That is why acceleration was 0 meters per second. Hope you are following. Okay. Calculate the displacement. So displacement is the same as the distance. Calculate the displacement of the car while its velocity was increasing. So they want us to calculate the displacement of the car while its velocity was increasing. So if you check this velocity time graph, the car was increasing here. So we're going to say increasing. So the car was increasing. Remember, the car started from rest here, from zero, then it started increasing. So they want us to calculate this displacement. And this displacement, they want is the triangle. So they want us to calculate this displacement, which is of a triangle. So what are we going to do here? So we are going to use a formula. We are going to say, so this is our what, this is our C. So we are going to say x is equals to half times EH. Okay. So we want us to find the displacement here. So we are going to use this formula to say x is equals to half times z base times z height. So we have our base here. This is our base. Then we have our height there. So what are we going to do here? So we are going to say half multiplied by the base. This base is 2 multiplied by 2 multiplied by the height. The height is this is the height. The height is 30. Okay, so this will cancel. So our x is equals to 30 meters. So that is our answer. So we have found the displacement of the car while its velocity was increasing. So it is 30 meters. That is the distance. The displacement is the same as the distance. Okay. So let's also consider this other question. They are saying what? Calculate the resultant force on the car during its acceleration. During its acceleration. They want us to calculate the resultant force. So in this case, when you vividly look at this question, they have given us the mass. And we have also found acceleration in one of the questions here. So they want us to what? To find the resultant force. So in this case, here we are going to use the Newton second law of motion. So this is our what? Okay, this is our D. So we are going to say force is equals to mass times the acceleration. They have given us the mass there. So we have 1,200 kg multiplied by acceleration when it was increasing. Acceleration when it was increasing. And what have we found there? When it was increasing, we found that it was 15 15 meters per second. So what is our force? Let me just get a calculator. What is our force? Okay. So our force is 18,000 newtons. That is the force. Oh, we are following. This is the force that they wanted us to calculate. So this is the what? The resultant force of the car during its acceleration. Okay, let's proceed. We have E also here. E. Okay, we have E. E, they are saying what? Distinguish between its speed and the velocity. And this one was 1 mark. So they want us to distinguish between its speed and the velocity. How do you distinguish speed and velocity? You can take note of just the word speed. Speed starts with the letter S. Speed. So speed is a scalar quantity. Velocity starts with V. Velocity is a vector quantity. Right, so that is our E. So speed is a scalar quantity, while velocity is a vector quantity. Vector quantity, they are both magnitude and direction. Okay, let's proceed. We are on F now. F. So you need to answer all the questions here so that you can get all the marks. So we are on F. What is F asking us to do? Calculate the displacement of the car for the whole journey. So let us be expectant of such a question. So they want us to calculate the displacement, which is the distance. The distance for what? The distance for the whole journey. The distance for the whole journey. So this question can be answered in two ways. There is a way where you can find the distance of the whole journey, like they have said, or since we have found the distance of when the car was accelerating, was increasing here, we can also calculate the distance of this other part. And when you look at this structure, let me get a different marker. Okay, so when you look at this structure here, this structure here, this is a trapezium. This is a trapezium. This is a trapezium. This was a triangle. Triangle we already found. So we are going to find now for the trapezium. This is a trapezium. This structure is for a trapezium. So what are we going to do? So trapezium, we are going to say x is equals to half. It has also a formula on its own. Half divided by a plus b, then you multiply by what? Multiply by h, which is the height. So we have a multiplied by the base multiplied by the height there. Okay, so what are we going to do here? Let's consider. So what is our a? So our a in this case, so this is our a and this is our b. So this distance is our a. This is our b. Right. So our a is this one, right? So we are going to get the the number from the time here. So when you look at between 4 and 2, what is the difference? The difference is what? The difference is just 2. So you are going to say 2 is A plus. We have the B. I'll say this is B. This is A. So this is the distance. So the difference between 8 and 2 is what? It is 6. Then what is our height? Our height is this one. So our height is what? Our height is 30. That is our height. It is 30. So we're going to multiply by h this side. So because my space, I will work out this side. So x is equals to, right. So this is going to be half multiplied by what? This is sorry, the height we have said is 30. Okay. So we are going to this plus this. It's going to give us what? 6 plus 2 is going to give us 8. And we are following the body mass. We first work out the things which are in the brackets. Always remember, first you work out things which are in brackets. We are following the body mass. Brackets of, so we are following first the body mass. So when you add this in brackets, they are giving us 8. So 80 we will multiply it by 30. Okay, like that. Okay, so automatically here we can simplify. So this is what? This is 4. So x is going to be 4 multiplied by 30. 4 multiplied by 30, which is 120. 120 meters. So this distance, or rather this displacement we have found, is only for the trapezium. It's not for the whole journey. So this is where now we add the distance of the triangle plus the distance of the trapezium. So we are going to say the distance of a triangle, which you find where is the distance of a triangle? This one here. So we are going to say 30 plus 120 given us what? This is the 150. This is giving us 150 meters. This is the distance. Now, this is the displacement for the whole journey. If at all you need help for sciences, chemistry, physics, biology, mathematics, you can just reach us on this number 0974 93 00 Thank you.